I'm going to discuss triangle under building construction, which actually covers theory of structures. Triangle facilitates calculation of space, power, strength, and stability can be derived. The triangle is considered undeformable. Triangle method, a graphic technique for finding the vector sum of two concurrent forces by displacing one force vector parallel to itself until its tail coincides with the head of the other and completing the triangle with a vector that represents the resultant force. Triples and three-hole loops demonstrates the structural rigidity of the triangle. Such construction cannot collapse under the influence of external forces acting on it and does not permit any movement. This rigidity is expressed by the formula P equals to 2L minus 3. Example, verify the rigidity of a steel truss having 15 poles and 9 loops. Verification of rigidity. So, verification of rigidity equals to 2L minus 3. So, 15 equals to 2 times L. L is 9 minus 3. Therefore, 15 equals to 15. So as you can see here, we already have designated the corresponding numbers, which actually denotes the number of poles, which is equivalent to 15. Now, the number of loops is actually 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is why we were able to designate L as 9. So the formula for the verification of rigidity for this truss is P equals to 2L minus 3, which denotes that the formula for this verification of rigidity for the loop balancing method is 15 equals to 15 for two-dimensional plane frame. Second, space frames. Structures which are near to the square in plan, such as exhibition and convention halls, are more likely to adopt vertical support for their roof on a rectangular grid composed of bars having few different sizes. This system can be economical, but it is disadvantageous in terms of stability. Alexander Graham Bell, an American electrical engineer and one of the inventors of the telephone, initiated the use of three-dimensional triangulated frame in space. This structure is made up of bars forming pyramids with bases in upward or downward position, creating two parallel horizontal grids of bars interconnected by zigzagging bars in at least 3 directions. From this concept, large spaces can be covered with lighter but more rigid structures. This space frame led to the construction of different types of roof, which are built using a modular system. This assembly is easier, thus gaining an economic advantage and at the same time producing visual impact. A three-dimensional structural frame based on the rigidity of the triangle and composed of linear elements subject only to axial tension or compression. The simplest spatial unit of a space frame is a tetrahedron, having 4 joints and 6 structural members. As with plate structures, the supporting bay for a space frame should be square or nearly square to ensure that it acts as a two-way structure, also called space frame. One of the most important structural innovation of the 20th century is the Judaic Dome, designed by the American architect, engineer, and inventor Buckminster Fuller. This dome is built with space frame copied from nature, as in the structure of crystals and plant cells. Theoretically, this structure can enclose an area of any size. In spite of the possibilities presented by the invention of the space frame, it was not widely used then because the design requires time-consuming mathematical calculation. It was only with the advent of the electronic computers that it was deemed practical to utilize. Space frame, the formula is pole equals to 3L minus 6. 24 equals to 3 times 10 minus 6. 24 equals to 24. Let us go over this verification of rigidity loop balancing method. So here we have number of poles is 24. So let us count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and 23, 24. So there are actually 24 holes. Then the number of loops is 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is why we have 10 number of loops. Using the formula for this, pole equals to 3L minus 6. So therefore, pole is 24. As you could see here, there are 24 poles. Which is equivalent to 3 times 10. 10 loops minus 6. Therefore, 24 equals to 24. So we have three-dimensional space frame. So under the Rendell truss, a frame beam structure having a vertical web member rigidly connected to parallel top and bottom chords. A Virindle truss is not a true truss since its members are not subject to axial bending forces, also called Virindil girder. Dome. So a dome is a curved roof structure spanning in area, often spherical in shape. A vault, substantially hemispherical in shape, but sometimes slightly pointed or bulbous. A ceiling of similar form. So one classification of dome is the radial dome, a dome built with steel or timber truss against arranged in a radial manner and connected by polygonal rings at various heights. Swindler dome, a dome having steel members which follow the line of latitude and third set of diagonals completing the triangulation. Lattice dome is a steel dome structure having members which follow the circle of the latitude and two sets of diagonals replacing the lines of longitude and forming a series of isosceles triangles. Judaic Dome is a steel dome having members which follow three principal set of great circles, intersecting at 60 degrees, subdividing the dome surface into a series of equilateral spherical triangle. Method of section. We have the free body diagram. It is the sketch of the structure of its section with all supports removed and the forces on those supports drawn in sketch. Moment arm is the perpendicular distance between the line of action of the force and the center of moments. Reaction is the resistance that they develop to counteract and the action of the bar upon them. For a system to be in equilibrium, the sum of the external forces acting on the system must be zero. Perpendicular lines creates a right triangle. Method of sections uses the following four concepts. Can be used to calculate forces in the member of a truss using the method of section. The concept, letter A, moment, force times perpendicular distance from point of reference. Letter B, in a static system, the sum of applied vertical forces equal the sum of the vertical reaction. Letter C, in a static system, the bending moments around any point are zero. D, components of force. A force can be described as two separate component forces acting at right angles to one another. Let us discuss here sample problem. So you will see here the truss below. So you need to solve for the force of member CF. Determine if the force is working, if it is compression or tension. To determine the reactions, use the free body diagram to simplify the solution when solving for the reaction. Simply add all forces acting on the truss. 20 plus 20 plus 20 plus 20 plus 20 equals to 100 kilonewton. Take note, 100 kilonewton, put it at the center of the free body diagram. Hint, if you're going to use the method of joints, it will take you quite some time to arrive at the member CF. The quickest way to arrive at that member is to cut the truss into portion. The best location is to cut it in between the web member of C and F. Then use the left portion to solve for the problem. Take moment at A to eliminate C, E, and DF, meaning C and E and DF is 0 immediately. So we are able to eliminate unknowns already. What is left is just member CF. Determine the force acting on member CF. So meaning we need to determine here this member C and F. Identify if it is tension or compression. Solve the truss using the method of sections. So take note to solve for the reactions of A and reactions of B. So simply we need to count how many loads are here. So 1, 2, 3, 4, 5. So 5 times 20 is 100 kilonewton. So because the span here is 30 meters, if you're going to divide it, it becomes 15 meters. So therefore, W2 equals to 100 kilonewton divided by 2 equals to 50 kilonewton. So meaning your reactions for A and reactions of B, they're both carrying the load, which is actually subdivided into 2. That is why we were able to gain here 50 kilonewton under the free body diagram. So this is the blown up part of the section of the truss. So take note, we need here the left corner to analyze the problem. So here we need to benchmark it at F. So the benchmark here, if we're going to look at the members C and F, so we need to understand how much is the distance from this span till it reaches the base and up to the highest portion of the truss, which is actually equivalent to 5.76. So here we need to solve for the reaction using the free body diagram. Solve for the reaction of A. Summation moment at A is 0. Clockwise direction is negative and counterclockwise is positive. So reaction of A equals to 30. So meaning reaction of A, if we're going to benchmark it at this direction, so reaction of A times 30 minus 20 kilonewton. So here, this is already considered to be our clockwise motion, which is negative. So therefore, 5, 10, 15, 20, 25. So the span here is 25 meters. That's why here you could see that 20 kilonewton times 25. Then the moment arm is divisible by 30, 25, 20, 15, 10 till 5 meters. All in all, reaction of A equals to 50 kilonewton, which actually supports our load here. So this is actually the long cut method. So solve for the reaction of B. Summation of forces vertical. All forces vertical is positive and all downward forces negative. So therefore, force of B 100 kilonewton, which is actually the load here. minus 50 kilonewton. Therefore, R of B is 50 kilonewton. This is how we were able to solve for R of B. Now, solve for the height of the web member using tangent 30 degrees. Height equals to 5 meters. Height, therefore, tangent 30 degrees is 5 meters. Height, therefore, is 2.88 meters. This is how we were able to compute this side. While for number 4, solve for the height of the other web member of the truss. So by using ratio and proportion, 5 meters divided by 2.88 equals to 10 meters times x. X therefore is 5.76, which is this. So using ratio and proportion. So meaning you can get the right triangle here, then eventually the other right triangle here. That is why we were able to come up with the ratio and proportion, which is equivalent to 5.76. So using under number 5, the left side of the truss, solve for the hypotenuse of the member CF. So hypotenuse 5 squared plus 2.88 squared. Hypotenuse therefore is 5.77. So meaning you're able to come up with same answer as this. So for number 6, to solve for the CF, take summation at A is 0. So moment at clockwise direction is negative, and moment at counterclockwise direction is positive. Negative 20 kilonewton times 5 meters plus CF is 2.88 divided by 5.77 meters times 10 meter equals to 0. So therefore, we have negative 100 kilonewton meter plus CF is 4.99 meters equals to 0. CF vertical therefore is equivalent to 20.4 kilonewton. So therefore, CF vertical is 20 kilonewton. This is our answer. So this is CF vertical. So meaning take moments at A. So therefore we are able to eliminate members CE and members DF. Now if we're going to put it here to this direction, CF vertical therefore is you're able to use already the CF vertical to benchmark at this moment at A. This ends the solution.